In this video, I'm going to continue question number 18, the second part, problems 2.3 from elementary number theory by D.M Burton. The second part of question number 18 says that we have to prove that the product of any four consecutive integers is divisible by 24. Okay, suppose we have four consecutive integers. a plus 1, a plus 2 and a plus 3 are any four consecutive integers. We have to prove that the product of any four consecutive integers is divisible by 24. Okay, here we are going to use a mathematical induction, okay, and also we have to use the first part of question number 18 in order to prove the second part. Let's do that. First, when a is equal to 1, then we have a into a plus 1 into a plus 2 into a plus 3 to be equal to 1, and then into 2 into 3 into 4 when a is 1. This is 24, and 24 is divisible by 24. Okay, now when a is equal to k, when a is k, then this one becomes k plus 1, k plus 2, k plus 3. Suppose this one is divisible by 24, then we can write it as a multiple of 24 into some integer p, where p is an integer, suppose. Then we shall prove that the result is also true when a is equal to k plus 1. Now when a is equal to k plus 1, this one becomes k plus 1, k plus 2, k plus 3, k plus 4, okay, when a is equal to k plus 1. Now this one can be written as k into k plus 1 into k plus 2 into k plus 3 plus 4 into k plus 1 into k plus 2 into k plus 3. This one is exactly equal to this. Okay, now have a look here. This one is equal to 24p because we have assumed that this is divisible by 24. So in place of this one, what do we write? We write 24p. Okay, and then here we have 4. Now what about this one? This one follows from the first part of question number 18. See, we have shown that in the first part that this is divisible by 6. Okay, if that is the case, then k plus 1, when a is equal to k plus 1, here we have k plus 2 and then k plus 3, this is also divisible by 6, if this is divisible by 6. Okay, so what can we write? This is divisible by 6, so we can write this one as a multiple of 6. Say 6q, where q is some integer. Okay, p is also an integer. From here we have 24p plus 24q. Alright, now here we have 24 into p plus q. P is an integer, q is an integer, then we get another integer, say r. R is an integer. Okay, now see, we have shown that this one is a multiple of 24. Okay, That is, this one is a multiple of 24 when a is equal to k plus 1. So it implies that 24 divides k plus 1 into k plus 2 into k plus 3 into k plus 4. So the result is also true when a is equal to k plus 1. So by mathematical induction, what do? We conclude that 24 divides the product of any four consecutive integers. Okay, so this is how we use a mathematical induction and the first part of question 18. And in the next video, we will continue with the third part. The third part, we have to use a mathematical induction plus the second part of the question number 18. Okay.